Hello, this is Mrs. Plenda here with another video on factoring. Now last time we talked about our greatest common factor, and so we're going to start there. The thing that I want to talk about right now though is that this greatest common factor could be a binomial factor. So in my first example, I have 5 times m minus 2 and negative m times m minus 2. So these two pieces are each multiplying with m minus 2. That makes m minus 2 their greatest common factor. So I will take that and I will pull it out front. And then I will write what was left from that multiplication. So 5 and negative m. So our new step this time is that this greatest common factor could be a binomial factor. Because factor just means that it's multiplying with the rest of it. So 2b is multiplying with b plus 3. 5 is multiplying with b plus 3. They both have b plus 3 in common. That is their greatest common factor. Then I write the leftover multiplying pieces, the 2b and the plus 5. So we're going to take this to the next level and do what is called factoring by grouping. That is where I take a 4-term polynomial and find the greatest common factor, not once, but twice, well, technically 3 times, I guess, so that we can reduce this to 2 factors that are multiplying. So the first thing we do is split our 4 terms down the middle, so I'm just dealing with 2 at a time. Then I'm going to find that greatest common factor in each half. So let's look here at our first half. Our greatest common factor between 4b cubed and 6b squared is going to be 2b squared. When I divide that out, so 4b cubed divided by 2b squared gives me 2b. And negative 6b squared divided by 2b squared gives me negative 3. So there's my first step. I've pulled out that greatest common factor, just like we did in our first lesson, out of that first binomial pair. Now I'm going to do the same thing for the second binomial pair. I'm going to look for that greatest common factor, which in this case is 5. And I will divide that out of the 2 terms. So 10 divided by 5 is 2, still have the b. Negative 15 divided by 5 is negative 3. And so now, see how I have this common binomial factor in each spot? I'm going to take that common factor out to the front. That's my binomial greatest common factor. And then I'm going to write these other 2 pieces that were left behind. So I've got that 2b squared here. And I'm going to put the 5 here. And since it is a positive 5, I will write plus. And now I have completely factored this 4-term polynomial into 2 pieces that are multiplying. And if I took these 2 pieces and wanted to check, I could multiply them back together. And I should get back to this first spot. So let's check that real quick. If I were to multiply these 2, so I've got that 2b minus 3 and 2b squared plus 5, and let's multiply. That will give me 4b cubed. That will give me 10b. Let's do the second part. That will give me negative 6b squared. And that will give me negative 15. Are those all the terms that we had in our first phrase? Well, 4b cubed, 4b cubed, 10b, 10b, negative 6b squared, negative 6b squared, negative 15, negative 15. So if we ever want to make sure that we factored it correctly, just reverse the factoring process by multiplying, and we can know whether or not we did it correctly, right? Checking your work is always a good idea. So let's do a couple more examples to factor. First, cut it in half. Then look for that greatest common factor in the first half, which will be 2m. Divide it out, so 2 divided by 2 is 1. 1m, oh, I should do 2m squared here because that's the least number that I see. So then I will have just 1m left. 4 divided by 2 is 2. I've already got both m squareds out front here, so we're done. Then let's take a look at the second half. Greatest common factor between 6 and 12 will be 6. There are no letters over here, so there will be no letters in our greatest common factor. 6 divided by 6 is 1, still have the m. 12 divided by 6 is 2. I now have this matching binomial phrase in each place, so that's my new greatest common factor. I'll write that out front. Then I've got the leftover pieces, this 2m squared, and this 6. Because the 6 is positive, I will write plus 6. There we go, all done. Let's do another. Split it in half. Take a look. Any common numbers between 7 and 2? There are not. 2 does not go into 7. So the greatest common factor will only be 1. And then I take the least number of x's that I see and divide it out. 7 divided by 1 is 7. Still need one more x. 2 divided by 1 is 2. Don't need any more x's. I've got both of them right there. Boy, this plus is giving me issues. There we go. Then we do the same thing with the second half. What number goes into both 28 and 8? Well, 8 doesn't go in evenly, but 4 does. 28 divided by 4 gives me 7. Still need the x. 8 divided by 4 gives me 2. Now I can see I have this same phrase. So that's my new common factor. I'll pull that out to the front, just like we have pulled all our greatest common factors before, and then write those other pieces in a second set of parentheses, just like we have before. There we go, fully factored. So we're finding that greatest common factor once and then twice, okay? So double greatest common factoring. Let's do it again. Split it in half. Now we're going to watch these signs as we go through this because we want to make sure we're putting them in the right places. So greatest common factor between 6 and 9 is 3. Least number of a's is squared. 6 divided by 3 is 2. Negative 9 divided by 3 is negative 3. We've already got all our a squareds. All right, let's do the second part. Greatest common factor between negative 8 and 12. Well, notice that I've got this negative in the front, but what's my first term inside the parentheses? Positive. That means I need to divide this negative by a negative. That will give me a positive inside my parentheses. And the greatest common factor between 8 and 12 is 4. So I'm going to pull out negative 4. Negative 8 divided by negative 4 gives me positive 2. See? Now it matches what I was looking for. 12 divided by negative 4 is negative 3. Again, that matches that first parenthesis set. So now I've got that greatest common factor binomial. So I can pull that out to the front. And then I write what's left in parentheses. Over here I've got 3a squared and negative 4. Good to go. Last one. Again, we want to watch those negatives because signs can always be a place where we make mistakes in algebra, right? I also see that this should be a b instead of an x. There we go. That's going to work out much better for us. All right, now greatest common factor between b cubed and 4b cubed, or 4b squared, will just be 1b squared. Divide that out. I'll need one more b to make b cubed. 4 divided by 1 is just 4, and I've already got my b squareds over here. Take a look at the second half. Again, I've got negatives here, but I want positives inside my parentheses, so I better factor out a negative. Greatest common factor between negative 2 and negative 8, well, negative 2 does go evenly into negative 8, so that's what we'll pull out. So negative divided by a negative gives me positive, and a negative divided by a negative gives me a positive. And we can see there we have our beautiful matching binomials. That means that's my greatest common factor. I'll pull it out front. And write what's left. 1b squared minus 2. We have factored that. Now I know what you're thinking, but Mrs. Plenda, I hate distributing, and this grouping makes no sense to me. You know what? That's fine. I have an alternative way to do this for you. Just like you can multiply with the box and you can find greatest common factors with the box, you can also use the box to factor these polynomials of 4 terms. So first thing that we do, we're going to draw a box. And because I have 4 terms, I need 4 spaces inside my box. And I'm going to put the first term in the first box. And the, this one's supposed to be a plus, my bad. And the last term in the last box. And the other 2 don't really matter where they go. I just sort of, you could put them anywhere. It's going to work out either way. Okay. Now, first step. I'm going to look for that greatest common factor. Still have to do that in each row. So looking at this first row right here, I'm looking for that greatest common factor. They don't have any numbers in common, but they do have x squared in common. And looking at this bottom row, looking for that greatest common factor between 5x and 15, I've got 5. So after I pull these out, this greatest common factor, what am I left with? Well, if I pull x squared out of x cubed, I still need one more x. If I pull x squared out of 3x squared, I still need 3. Now let's double check. If I pull that 5 off of this 5x, am I left with an x? If I pull 5 out of 15, am I left with 3? Absolutely. So then I can see that I have my factors on the side. X squared plus 5 because they're both positive. And on the top, x plus 3 because they're both positive. And there, we have just factored it. One of the really nice things about this box is that ability to self-check. If these guys multiply back in properly, you know that you have correctly factored it. Okay, let's do a couple. All right, let's do 4. So because I have a 4-term polynomial, I need a box with 4 spaces. I put the first term in the first space, and I'm just gonna go ahead and throw the rest of these in here. I'll rearrange one of these so that, we can see that it doesn't really matter where they end up. I look for that greatest common factor across the top row. I see that I have a 2, so I can definitely divide 8 by 2. And I've got a squared. Looking for that greatest common factor across the bottom, I can divide 12 by 3, so that's what I'll pull out. And then we're looking for what's left. Well, what else do I need to get to 2a cubed? I need an a. What else do I need to get to negative 8a squared? I need a negative 4. Let's double check. 3 out of 3a, do I need another a? 3, negative 12, do I need a negative 4? So there's our factors. 2a squared plus 3 and a minus 4. Next one. Because I have 4 terms, I need 4 spaces. I'll do 10b cubed here. I'll throw the negative 16b squared down here. 25b and negative 40. I'm going to pull that greatest common factor out of the top row. Looking between 10b cubed and 25b, I can definitely pull a 5 and a b. Looking at negative 16b squared and negative 40, I can pull an 8. And because they're both negative, I'm going to make it negative 8. Now, taking a look at this, I've got 10b cubed divided by 5b. Well, I need 2 and b squared still. 25b divided by 5b, I still need 5. Let's double check. If I divide negative 16b squared by 8, do I get 2b squared? Sure do. Negative 40 divided by 8, do I get 5? Sure do. That's how we know we did it right. 5b minus 8 and 2b squared plus 5. Those are my factors. Here we go. Couple more. Because I have 4, I need 4 spaces in my box. 10x cubed, 4x squared, 5x, and 2. Looking for those greatest common factors. Looks like it's going to be 2x and 1. Let's double check. 10 divided by 2 gives me 5, and I need 1 more x. 4 divided by 2 gives me 2, and I've got all the x's I need. Do these match back up? 5x divided by 1 is 5x. 2 divided by 1 is 2. Yep, they sure do. So I've got 2x squared plus 1 as my first factor, and 5x plus 2 as my second factor. Last one. 4 terms, 4 spaces. 2x cubed minus x squared minus 6x plus 3. Looking for that greatest common factor across the top. Looks like it's just going to be x squared. Looking for that greatest common factor across the bottom. Looks like it's going to be 2. Wait, nope, sorry, 3. 6 divided by 3 is 3 is 2. The greatest common factor will be 3. I see I have a negative here, so I'm going to put a negative here. Now, 2x cubed divided by x squared, I still need the 2 and an x. Let's go ahead and double check. If I've got that negative 6 divided by negative 3, that does give me positive 2, and there's the x I still need, so matching up so far. If I've got negative x squared here and a positive x squared, I need a negative 1 up top. And if I have negative 3 times negative 1, that does give me positive 3. So it looks like things match up. Okay, we've got to pay attention to those negative signs. They are important. And 2x minus 1. There's my factors. So just like multiplying, you can factor by grouping using finding that greatest common factor twice and undistributing. Or just like multiplying, you can multiply with the box, you can factor out of the box. You multiply in, you factor out. You pick your favorite way, get to know it, get to love it. That's all you got to do.